Greetings from Quickmill. My name is Dave Piggott. I'm Technical Director of the company. And let me say this first of all. Please don't expect a fancy Hollywood production from this video. This is a made at Quickmill video, and it's strictly for information for our customers and future customers in the heat exchange industry. And the purpose of this video is to explain a new technology that we have developed called quick scanning. Currently, for example, header boxes can be machined in one of two ways. You can take them to a manual radial drill and using high-speed steel tools and very high labor content basically machine them on the radial drill. That's method number one. Method number two, you can probe every hole, and then you can put the part on the CNC machine and machine it with carbide tools. Now let's talk about that just for a moment. Probing is a very, very slow way of identifying where holes are in a header box. It can take upwards of 30 seconds per hole to identify where each hole is and its Z position error with a probe. More often than not, the probing methods offset a lot of the savings that you would otherwise expect on the CNC machine because of its speed. Now, Quickmill's quick scanner is a non-contact method of finding out where those holes are in the X, Y, and Z position. It'll identify where a hole is in a little under a second and a quarter for each hole. Now, when you start adding numbers up on a typical header box of, say, 500 holes, you're going to spend 4 hours more probing that box than you would spend if you scanned that box with the quick scanner. So I don't have to do any math with anybody watching this. That is remarkable in time savings. Well, enough talk right now. I'd like to show you the tools that we'll be using to machine the header box, and I'll also show you the scanning head, which relates to the quick scanning system. Okay, I wanted to show you the 5 tools that we'll be using during this video. First and foremost, we have a boring tool with 2 inserts, and this does a beautiful job of making very straight, very smooth, and very non-elliptic holes. Secondly, we have a grooving tool here, and you'll notice that it has little outlets. I don't know if you can see it, but it has little outlets for coolant to go right through the tool and keep the chips away from the groove that you're milling. Third, we have a facing tool here for spot facing the plug side, and I put a little plug here. The whole purpose of these last 3 tools is to create the threads and the sealing face for the plug. The first tool that we'll use after boring, of course, is the spot facing tool. Then we will chamfer the holes with a chamfering tool. This has 2 teeth in it, or 2 inserts. And finally, we're going to use a spiral tap for tapping the holes. Now, I will make one short comment here. When we used this spiral tap, it was very slow in the video. I would suggest for people with more up-to-date tapping tools that they mill the threads in with a thread milling tool. It's far better and far, far faster. Also, before we go out into the plant and see things running, I wanted to show you one of the major components of the scanning system. This is the head that actually does the scanning. It's mounted in a special Cat 50 holder, and out of here comes a laser beam, and the average scanning distance for this is about 6 inches, plus or minus about 1.5 inches. And the remarkable part of this scanner head is that it sends back signals to the quick scanning system at 20,000 cycles per second. So it's not a toy. This is a seriously made, very, very fast scanning head. Alright, the component which we need for rapid scanning is the computer which is in the red box to the side, and I'm going to open this up and show you what it's all about. Now this computer is mandatory in the whole system of scanning. This computer does all the work of data storing, and it also communicates with the FANUC CNC machine, which of course is located on the left. And finally, this computer is used to create instantly a program for the operator based on what the scanner has found on the part. Now this is very important to realize, that this computer does a lot of work and in the end creates a program from the scan hold instantly for the operator. Right now I want to explain to you what the operator does and how scanning physically works. You'll notice here with my little pointer there's a little red spot here. This red spot has been located by the operator. The operator takes the scanning head and physically, himself or herself, moves the little red scanning spot close to the center of the first hole. Now you may ask, why does he or she have to bother doing this? Well, the main reason is, there are two reasons rather. One is we need to know the diameter of the holes, and two, we need to know the position of the first hole. Now when the operator has set this little red spot to the right place, it makes a quick move. Watch this. There. That's all it takes to identify where the first hole is and its XY position and its diameter. The next step is that the operator starts his scanning program. And away it goes. You'll notice that scanning, first of all, is done on the right side of the hole, and on this row there's about 38 holes. We're coming back now. Keep your eye on the little red mark. It's now on the left side of every hole. Now remember, these holes are not in a straight line. These holes are bigger, they're smaller, they're left, they're right, and also the line is curved. End of the first row, and it just begins and scans the second row. And this goes on and on and on until the part is fully scanned. Now I want to show you a little white object that's on top of the header box. This is a little object which is our, I call it our super duper little leveler. And what you have here is two circles and a bubble in the middle. Now when the level is tipped 15 degrees, or sorry, 15 thou on its diameter, the little bubble goes to the outer ring. And we found with a lot of header box manufacturers that they'd like to keep their slope within 15 thou over the base diameter of this, which is equal to the plug face diameter. So this little tool is very, very handy for very quickly setting up the header box in the right position. Now, first of all, I want to look underneath the header box and show you the jig itself. You'll notice that there are two pieces to the jig, one on the right and one on the left. Now the one on the right allows the right side of the header box to go up and down as much as an inch. The left jig is fixed. So you can tilt the header box tremendous amounts rather, left or right. Screws. Now one other thing I want to show you about the jig is two bars that run across. Notice there's two bars that run from jig to jig. Those are there because if you try to clamp the part between the two jigs, the clamping pressure will spread the two jigs apart. And so these jigs, two in total, won't tend to spread apart because of those two bars linking the two jigs at the top. So we're ready to go now to the next phase of it, which is the machining operation. Alright, what we're doing right now is boring the holes out. And there's things I want to tell you about. The tool is running at 1500 RPM and cutting downwards at 8 inches a minute. Alright, what we see here is the 4-point grooving tool. It is a circular interpolating 2 grooves in each hole. It's going 1340 RPM and 16 inches per minute as it circular interpolates the groove. And those of you with a stopwatch, you'll notice that the time is about 9 seconds per hole. Alright, here we go on the second operation for the plug side. Again, we're operating with 1000 psi through the spindle, so it's quite messy to actually film. The cutter is running at 1800 RPM, and the feed is 5 inches a minute. And it has a half-second dwell at the bottom of each hole. And for those with stopwatches running, we have a time of about 5 seconds per hole. Alright, now here we have chamfering. This chamfering is done to make sure that there are no disruptions in the sealing surface of the plug due to tapping into the bore that we previously bored out. Now these holes are going quite quickly. The speed is 1200 RPM. And the feed is 9.6 inches a minute. And for you that are stopwatch oriented, each hole is taking 2 seconds. What you see here is what is called rigid heck tapping. Now you may ask, why do we do this? Well, the spiral flute tap that you see operating there makes long, thin spirals of metal, and they get all tangled around the tool if you don't use this sequence. Now if you were to use a tap with a tap that feeds towards the bottom of the hole, then you wouldn't have the issue of bird nesting, but we want to use a spiral tap and keep the chips out of the hole. Well, it's time to summarize. First of all, I'd like you to think about something. Assume a header box with 546 holes in the part. The time to machine this box on a radial drill is around 12 hours, a little over 12 hours. If you use the quick scanning system and machine the box on a CNC machine, you're going to take 5 hours to do that box floor to floor. This represents 41% of the time that you'd otherwise use doing it by hand. And as a footnote, if you probe the box and then work the CNC machine on it, you're going to use another 4 hours probing rather than cutting metal. Now, cost reductions like that, in a word, using the quick scanning system are enormous. And I wish to thank you for bearing with me here and for joining me in this journey through quick scanning. And of course, I'll ask you to call Quickmill's salespeople if you want details about the new system. Thank you very much.